Part 1 of Lesson 3.3 is on properties of logarithms. We're going to begin by introducing these properties and then applying them to some problems. Before we do that, let's review our three properties of exponents. We have a product property, we also have a quotient property, and we have a power property. The product property talks about when you add your exponents. If you had 2 to the third times 2 to the fourth, that's when you'd add your exponents and get 2 to the seventh. And the quotient property tells you when you should subtract your exponents. If you had 3 to the fifth divided by 3 to the second, that's when you'd subtract your exponents and get 3 to the third. And then the power property tells you when you should multiply your exponents. If you had 4 to the second to the third, that's when you'd multiply your exponents and get 4 to the sixth. So just like we have three properties of exponents, we also have three properties of logarithms because they're very much related. Here they are. The first one is called the product property of logarithms. Please write it down. It basically says if you have the log of x times y, base b, you can rewrite that as the sum of two logs, the log of x base b plus the log of y base b. And then the quotient property right here, write it down, says if you've got the log of x divided by y base b, you can rewrite that as the difference of two logs, the log of x base b minus the log of y base b. And then the last property is called the power property, and if you've got the log of x to the p base b, you can rewrite that taking the exponent p and making it a lead coefficient. So you can change it into p log of x base b. That's the third one. Please write it down. Now we're going to start to apply these three properties to some problems like this. It's going to say express each logarithm in terms of natural log of 2 and natural log of 3. So basically we just have to rework this expression into natural logs of 2 and natural logs of 3. I'm going to begin by rewriting the natural log of 54 as the natural log of 2 times 27 because 2 times 27 does give us 54. That allows me to rewrite this using my first property, the natural log of 2 plus the natural log of 27. Now I got to change that natural log of 27, so I'm going to rewrite that as the natural log of 3 to the third. 3 to the third is the same thing as 27. And now this is a really good answer, except for we're going to take that exponent on the second natural log and we're going to make that a lead coefficient. So we write it as 3 natural log of 3. And this is written in terms of natural logs of 2 and natural logs of 3. Part B is similar. Rewrite this in terms of natural log of 2 and natural log of 3. So the first thing I'd do is I'd rewrite this as the natural log of 3 to the second divided by 2 to the third. Now I can rewrite that as the natural log of 3 to the second minus the natural log of 2 to the third, because when you've got the log of something divided by something else, you can rewrite it as the difference of two logs. And then my last step is to take those exponents and make them lead coefficients. So 2 natural log of 3 minus 3 natural log of 2. So we rewrote that in terms of natural logs of 2 and natural logs of 3. Example 1, same kind of problem, except for this time we're going to use common log of 5 and we're going to use common log of 3. So I'm going to rewrite log of 75 as the common log of 3 times 25. That allows me to rewrite it as the common log of 3 plus the common log of 25. And then I can rewrite that common log of 25 as common log of 5 squared. Move the 2 out in front, and we get our answer, 2 common log of 5, along with the common log of 3. Part B. Now we need to rewrite that 5.4, and we rewrite it with 5s and 3s basically. So I'm going to rewrite this as the log of 54 over 10, which is the same thing as the common log of 27 over 5. And so now my denominator is using a 5. That's good. So let's rewrite this as the common log of 27 minus the common log of 5. And now we'll rewrite that 27 as 3 to the third Then the last step is take that exponent and move it out in front. So we get 3 common log of 3 minus the common log of 5. So it's just rewriting these expressions using the 3 properties. There's a famous mathematician named Just Bürgi. He lived from 1550 to 1617. He was a Swiss mathematician, and he was a renowned clockmaker who also created and designed astronomical instruments. His greatest works in math came when he discovered logarithms independently from a guy named John Napier. Not sure if you've heard of John Napier. There's a good look at Just Bürgi, kind of a fun name to say. Example 2 now says we're just going to evaluate. Well, we've done some work like this, but they're just going to get a little bit harder. The first thing we want to do is put in an equal sign and an x, and now change it from log form to exponential. So 4 to the x equals the 5th root of 64. Now to get our answer, we need to get both sides to have a base of 4. So we're going to rewrite this as 4 to the 3rd, because that's what 64 is equal to. But since it's underneath the 5th root, we're going to raise it to the 1/5. Now using my properties of exponents, I can rewrite this as 4 to the 3/5, and now we know our answer is 3/5. Part B, now we want to use some properties of logarithms here. I'm going to rewrite this as the natural log of e to the 2nd to the 5th, that's using our power property, minus the natural log of e to the 3rd. And now I'm going to rewrite this first term as the natural log of e to the 10th minus the natural log of e to the 3rd. Then I can rewrite that as the natural log of e to the 10th divided by e to the 3rd. And now I can subtract those exponents and get the natural log of e to the 7th. And now my last step, what base is on this logarithm even though you don't see it? An e. So anytime this base and this base are the same, the whole thing just cancels out and we just get 7 for our answer. Another one. Let's put in an equal sign and an x. Let's change it from log form to exponential. So 6 to the x equals the 3rd root of 36. Rewrite this with a base 6. We get 6 squared is 36, but then that's raised to the 1/3 power. And so 6 to the x equals 6 to the 2/3. Thus, our answer is 2/3. And then part B, done very similar to the last problem, using some properties of exponents. Now I'm going to do this one slightly different. I'm just going to show you a different way of doing this one. But we can take this first term and just change it into a 9. And how can we do that? Because the base of this log right here is an e, and thus this whole part just cancels out and you just get 9. Plus, now here we could change this right here into a 3. Okay, kind of the same properties. All this cancels out, you just get a 3. So we end up getting a 9 plus 12, which is 21 for a solution. Day 1 homework problems are going to be 1 through 16. This will be collected Monday. We do have a day 2 coming up with expanding and condensing expressions.